Okay, so this video is going to pick up where we left off today in A block. If you were in C block, you saw the end of this problem, but I'm going to pick up here and then carry into a more general discussion about the types of problems that we were doing. So in A block, we finished with the information. We had found the vertex, the focus, and the directrix, and I'll get back in a moment to how we knew to find those based upon this problem, and in addition show another example. But we can start putting this information on. You can see that I have the vertex already placed, the focus placed here, and the directrix next to it. But what we want to realize is that the only one of those pieces that actually goes on the graph of the parabola itself is the vertex. We don't have any other points at the moment. So we remember that we have other methods for relations. Specifically, we have the ability to come up with the particular intercepts, perhaps the x-intercept or the y-intercept for the graph. In this case, because we know the direction that the parabola opens, we know that there are no y-intercepts because it's opening away from the y-axis. But we should be able to find some x-intercepts. So we have 2x equals y squared plus 8y plus 22. And I'm going to get 2x equals 22 or x equals 11. So out here at 11, 0, I'm going to have an x-intercept. That's going to be a point on the graph. It has to connect. So I'm going to change the color that I'm using for, this is the focus, right there. Let me make that in green. I'll make it clear that that's the graph itself. And because we know it's symmetric, we could also go down in the other direction, and we'd know that there's at 11, and what would probably be 11 minus 8 would be another point, and that would be down here. So if I went to draw this parabola, we'll get something that looks like this, and that's a pretty good picture of the parabola represented by this equation, this relation. So notice that while we started with new information in a new form, at the end, the x-intercepts allowed us to get a better picture when we finished. So before we move forward any farther, I do want to talk about generally where we came up with the vertex, focus, and directrix for this graph. And I'll do it by talking about a parabola, okay, any general parabola, with vertex h comma k. So the vertex, if we start with the form 4p times y minus k equals x minus h squared. Right? The vertex is as easy, the easiest of the three to find, as h comma k. And in the case where our axis is vertical, right, so our axis is vertical in this case, as we can see here. There's a vertical axis. We know that the focus is going to be on the same axis as the vertex. It's got to be just a certain amount above. How much farther? Well, the focus is p units away from the vertex. So I can always find the focus by taking the coordinates and thinking about which of the two has to change for based upon the axis. And when we have a vertical axis, that means that the focus is going to be above the vertex. So I want to move in the vertical direction. So I have h and k plus p. Those will be the coordinates of the new focus. And secondly, I have the directrix. And the directrix we know is a line. And that line is perpendicular to the axis, wherever it happens to be. We know it's going to be below this parabola. And its equation, therefore, because it's perpendicular to the axis, is going to be y equals something. And we know that it has to be the same distance away from the vertex as the focus is. So if the focus is k plus p, then the directrix must be at the equation k minus p. And these are all pieces that we can find from the general form. Right? That's the reason we develop the general form and why we come up with these pieces after we look at the general form. If we instead choose a different parabola, so if I instead choose a parabola which opens sideways, I'm still, in this case, I'm going to use the formula 4p times x minus h equals y minus k squared. I'm still going to end up with the same vertex. It doesn't change at all. It's still hk. But this time, I have to realize that the focus, because the axis is horizontal, the focus must be to the right of the vertex. And remember, when I'm saying right and up, I'm defaulting to positive directions. If we have a negative p-value, means it opens in the opposite direction. And we'll see some examples of this, so you'll see some examples of this in your homework. All right, but in this case, it means that my focus is going to be at h plus p, comma k. And it means that the directrix will have an equation of x equals h minus p. So those are our major pieces that we're interested in. And the next video will have to do with another example, and I'll additionally add one more piece that we care about for each problem.